Hello, this is part 6 of the water heater project, and this is the assembled unit as a demonstrator board. I did this a lot sooner than I thought I would. I was doing some rewiring, and I had to yank on this wire, and it pulled a couple other wires out of terminals, and I got all the wires back but one, and that caused a ground path from my control system over here. Like I say, this old one was microprocessor controlled, and what it did, it burned up this little resistor right here. I mean, it lit up, it was like a light bulb. And anyways, a capacitor blew up, a very little one that was on the power supply for the power meter. And well, I figured, you know, rather than just go back and fix that, I was going to put up this system here anyway. So I've tried to do this as a little demonstrator of how simple it can be and what a typical setup would be. I include the power meter. You want to do the power meter right off the panels, so the positive comes into the capacitor bank, and it also gets sampled on the positive pins. They have 2 pins for positive. You don't have to connect them both up. They're internally connected. It's just to sample the voltage. The current is censored in the negative lead, so it's actually the negative power coming in here from the panels, and that goes over into this meter, and from this meter it goes to the capacitor bank. And from the capacitor bank it goes to this top terminal, which is the minus. And you want to run this to the capacitor bank as short as possible, because this has a lot of high current pulses, and it'll put in an offset voltage that might screw things up. That lead should just always be as short as possible. But the 2 blue leads, these go to the water heater. They just tie together, and the other part of the water heater element goes to the positive, which goes up to the capacitor bank. Now this thing's a little different. I had the other heater set up with this temperature control, because I wanted to read the temperature, and you know, the switch was in there already, so I used that, and that comes through this little black wire. And so the sense resistor, this senses how much the panel voltage is, and it's adjustable by this pot, and then it just connects to this wire going down to the relay of the temperature controller and back up. So like I say, this is the modified board. You know, you can't use the board as it is. You have to pull out this relay, then you can insert the TL431. A couple little parts you have to do, and these heat sinks, there's the FETs mounted on those, and those have to be replaced because they used to put in 75 N75 FETs, and those were good for 75 volts and 75 amps, and that was okay for a 60 volt system. You couldn't do it with a 72 cell panels in parallel, I mean in series, but you know, it was at least 75 volts, and you know, on a 50 or 60 volt system that would be fine. But these have to be replaced with 110 N10s, and that's a 110 amp FET at 100 volts. And it's easiest if you know, take the center pin of the old one, just cut it while it's in here. If you remove the relay, it's easy to get a nipper in and cut the center lead, and then you're only unsoldering 2 leads, and that'll pull out fairly easily. You know, the instructions in the other video. But right now we're at 52.2 volts and 7 amps, and actually that's the maximum you can get into this, because it's only 50 volts at the power point, and you've already put everything you can into the heater, so it's just a direct connect right now almost. But this would be your water heater thermostat. As you can see, the power comes in, there's a 1000 ohm resistor across the switch, and this goes to the control system. That's the positive. Now, this is good for one important thing. In setting up the panels initially, you turn the system off, and you'll see that I've actually set the power point at 50.27, and you notice it's not taking any current. It's maintaining the voltage, but there's no current. It's acting as a shunt regulator. So if we switch this back, it goes up to the 51.3 volts. Now I'm going to turn on the refrigerator here, and you should see this drop out a little bit. Now you've seen the voltage drop down, but like I said, I got two charge controllers. They're still at 13.5, and my other water heater right now is at 214 watts, and I got 97 watts going into the battery from this charge controller. This is a 60 volt system, but that demonstrates how it works. When there is a load, it'll just drop off from the panels whatever it needs to give the charge controller enough to do whatever it wants to do with the battery. So that's it. Simple capacitor bank. This charge controller, once you do the modifications on that, it's a fairly clean setup. A pot to adjust. You can use an external temperature controller, or you can use the thermostatic switch. And if you use a temperature controller, you want to have some switch in there anyway, in case your panels have a lot more power than you can ever put into the heating element. So that's the demonstration. Thanks for watching.